Welcome to iteration 6 of the CS160 programming tutorial. In this iteration, we will extend the code from iteration 5 to begin addressing the computational and display requirements of the tutorial project assignment. Iteration 6 objectives include adding Java code to the main class to partially satisfy functional requirement 6. Well, what do I mean by partially satisfy functional requirement 6? Well, functional requirement 6 says that the program must compute the number of months required to pay off the balance using the equation in figure 1. Here's figure 1. Notice this equation is pretty complex. Let's take a look at some of the parts. B, which stands for balance, all right, that's an input. We already have code for that. P is the monthly payment. Well, we're required to do this equation for 3 different monthly payments. P1, P2, and P3 is what we named them in the program. So that's also an input. We've also written the code for that. But what about I? I is the daily interest rate. Note that the daily interest rate is derived from APR with this simple formula. Well, APR is also something that we've input. So in order for us to write any Java code for this equation, we first have to compute the daily interest rate. So when I say partially satisfy functional requirement 6, that's what we're going to do. We're simply going to complete all the code that's required to evaluate the right-hand side of this equation. In addition to that objective, we're going to continue to ensure that the variable names satisfy technical requirement number 3. We're going to add debug code to make sure we've implemented that formula correctly for the daily interest rate, and run the program to verify that the output produced by the debug code that we added does contain the correct value for the daily interest rate, and by adding that code we haven't harmed the code that we've used to input the required other values. As for code design, to partially address functional requirement number 6, the daily interest rate, that's going to be a decimal value because it's derived from another decimal value, the APR. So we're going to use a double variable to hold its value. And we're going to name it I to satisfy technical requirement 3, since it's designated I in the equation. And we're going to add an assignment statement using that formula, APR over 365, that computes the daily interest rate, and then we're going to store the results of that computation into our variable I. And then for the debug code, we're simply going to add one more output statement to display the value of I. So let's go back to our code. Well, first of all, we know we're going to need another declaration. So we'll put that right here. And we'll add a comment, since that's not descriptive at all. So we'll say that that holds the daily interest rate. And then if we scroll down, we'll notice that we actually have a step in our design called compute daily interest rate. All right, now we got to be careful here, because the daily interest rate is computed from the APR. And this is the equation that was given as part of figure 1. But one of the things we have to remember is the value for APR, when it's input, is input as a value in the range between 0 and 100. Well, Well, interest rates for computational purposes must be in the range between 0 and 1. So if we use this formula as given, we are not going to get the correct value for I, and we're going to introduce a bug into our code. So in order to get the correct value for I, we're going to have to take the APR that was input, and we're going to have to divide that by 100. Now I've done that in one step. You could easily break that into two. Also, you might be wondering, do we need to use double values for 100 and for 365? That is, since APR is a double, do we need to put decimal points and add zeros to the other values? The answer is no, we don't, but if we do, it does add clarification. The Java rule is if you have something that's a double and you do another operation, a numeric operation between it and something that's an integer, the result will be a double. Okay. So we can leave it as just 100 and 365, or we could add the zeros. Since I've added the zeros here, I'll just leave it like that. And then we'll add our debug code. And all we have to do here is simply print it out. All right, so that completes the code we have to add. Now we got to test it out. Now, in order to test this out, since this is a computation, we have to have some test case to compare it to. Well, when we were discussing whether or not we understood the requirements, we created some values to serve as test cases. So we'll use those right now. All right, so let's save the program and let's run it. Okay, again, we're going to have to add all the inputs that we had before. Oh, the APR. All right, we used 10 as one of our tests. Put anything for the credit card balance, and then I'll just add 1, 2, and 3 for the amounts. Okay, now we'll notice here that the value of I that comes out is displayed in scientific notation. Okay. But that is the value we expect. If we move that decimal point over 4, we'll see that it does come out to the 27 that we expected when we did the test. Okay, again, we're not in control of the format here, but just by inspection, we believe that this value is the same as the value we got on the calculator. All right, let's do one more that's a little different. Again, now this time we are going to use a slightly more complex value for the APR, something that does have decimal values in it. So we're going to use 16.75, something that's a little more realistic for the credit card percentage rate. And here we do get the value that we expected. Now, it's really critical that we have those values to test, because otherwise there would be no way of knowing that the value produced by I is the value that's expected. And we would go on developing the code. That is, the next thing we're going to do is actually compute the number of months using Formula 1. If that interest rate, that daily interest rate, is not correct, then the number of months is not going to be correct, and the rest of the output in the credit card payment report is going to be incorrect. So you can see it's really critical that before we begin coding, we have a very thorough understanding of the requirements, and not only that, but that we can manually, okay, produce the expected results. That is, create test cases where we use by hand, or if necessary a calculator, to produce what we'll call the expected results, and then compare those to the actual results that is produced by our program.